In this video, we will look at the DC to DC converter that's used to generate the 7-volt supply for the LCD display. There's a simple RC oscillator based around the two inverters inside IC2, which is the 74HC04. The oscillator would normally run at 1.2 kHz. If you use an oscilloscope, you should be able to see this. When we look at the schematic for the DC to DC converter, we can see on the left hand side the actual oscillator that's comprised of C31, R47 and R78. These combined with the two inverters give us the pulse output that's running at 1.2 kHz. The other four drivers boost the pulse drive capacity. The most common failure for this circuit, besides IC2 failing, is C31. When we test the board, we can see we're only getting 3.8 volts DC. When we look closer around C31, we can see some corrosion on its pins due to the leaky battery. At this stage, we just replace C31. When we test the circuit after replacing C31, we now see we're getting approximately 8 volts on the output. We are able to measure this on the positive side of C1 or C6. The first captured trace here shows what the pulse output should be like on pin 12 of IC2. The next trace that we have shows the pulse output shifted by the charge pump circuit. The last trace shows that we have a good DC output on the positive side of C1 or C6. When we test the LCD display back on the computer, we can see that the display is now darker than we had before, but we're still missing data on the display and the text is still not showing correctly. At this stage, I'll be shifting my focus to the LCD display module, and we'll cover this in the next video.